Hey, what's up, Bloomfield? Welcome to Mr. Wood's Awesome Math class. Today, we're going to be looking at how do we be able to graph functions, transform those functions from their parent functions as we prepare for our quiz. Good luck, and here we go. All right, so the very first function that we have here is an absolute value function, right? So when you have an absolute value, we know that nothing in here can be negative, so it turns everything that was negative and turns it to positive. So any x that was negative, so if I had, like, for instance, if I had a -1, absolute value of -1 is +1. So if x is -1, y is 1. If x is -2, y is 2. If x is -3, y is 3, and so forth and so on. Well, if it's 0, it's 0. At 1, it's at 1. At 2, it's at 2. And so we get this V structure here. All right, so the next problem here, we're actually transforming these functions. So I want to see what happens to each one of these. Well, this point that was right there, this tells me that because it's -2, I know I got to move that left 2. So I have to be able to move that to the left 2. So I'm taking that point that was there, moving it over 1, so moving it over to here, right? And then it says I got to go up 3, so I'm taking that and going up 1, 2, 3. So that point that was there is now right there. And everything else stays exactly the same. So my V now looks like this. So that is our transformed function. All right, if I want to, here we go, now I have a quadratic function, and I want to be able to graph this quadratic function. Well, when I graph a quadratic function, 0 squared is still 0. I know that when x is 1, y is 1. When x is 2, y is 4. And when x is 3, y is 9. And we get an axis of symmetry right down the x equals 0 line. And so I get the same exact thing on the other side. And it looks exactly like this. And there we go. There's our quadratic function. There is y equals x squared. And makes this nice parabolic curve, right? So there's that function. All right, well, if I wanted to transform that one, let's just once again look at just this one point right here first. And we got to go through just kind of like order of operations. So here, that's inside parentheses, so I would do that first. And if I'm doing inside parentheses, I know that this is going to move this to the right. So that's going to move it to the right. So I'm going to the right 2. So taking that point there, going over 2. And then it says I have to multiply it by 1/2. Well, I'm multiplying this by 0 by 1/2, so it stays exactly where it was. And then move it up 3. So that point then goes to right there. So that point goes to there, because what did I do? I moved it over 2, multiplied the 0 that it was, the y value, the 0, by 1/2, which doesn't change, and then moved up 3. Well, what happens to the point that's right there? That was, this point we know was at 1, 1, right? So I got to move it over 2, so I got to move it over to 3, multiply the 1 by 1/2, so it becomes now 1/2, and then move it up 3. Well, that becomes 1, 2, 3. So that would become that point there, and it would be exactly the same on the other side. So all I got to do now is look at that point. Well, that point I have to move, was it? This point was at 2, 4, right? So I got to move it over 2, so it goes over to 4. It's got to go up. Instead of being at 4, so instead of being at 4, we multiply it by 1/2, so that would be at 2, and then move it up 3. 1, 2, 3, and so now it's at 5. And it'd be exactly the same point over here. And there I can generate my quadratic graph, and it should look like that. We know that this is a vertical, so that's going to be a vertical shrink. So it's got to widen the graph, and so it should widen the graph out, which it does. All right, for number 5, well, when x is 0, y is 0. When x is 1, y is 1. When x is -1, y is -1. When x is 2, y becomes 8. When x is negative 2, y becomes negative 8. So I have this y equals, this is called a cubic function, right? So we have this function, and it looks like that. So there's that line, that curve. So if I want to move these around, let's start with this point, and let's move those around. Well, the first thing it says to do is do what? Always inside. So this would become plus 2, so that means I need to move it to the left 2. So I'm taking the point that was at 0, 0, move it over to the left 2. And then it says I have to multiply that by a negative. Well, I'm not doing anything with that because it's not multiple. So 0 times a negative doesn't do anything, right? And then I got to add 2. So that becomes then up there. So that would be that first point goes to there. The next point that was at 1, we're doing what? Moving it over 2. So moving it over 2. It was at 1. We got to multiply it by a negative, so it becomes negative 1. And then move it up 2. 1, 2. So it becomes right there. So that point is now there. This point that was up there. So it's at 2 and 8, right? So that's 2, 8. So when I move it over 2, it goes to 0. It's up here at 8 normally. We multiply it by a negative, so it flips down here to negative 8, and then move it up 2. So that would be that point. Same way over here, the point that was negative 1, negative 1. We have to do what? Move it over 2. So instead of at negative 1, it goes over to negative 3. It was at negative 1, but we multiply it by a negative, so now it goes to 1, and then move it up 2, and so it goes to there. And we can see the pattern in this other one. It's at 4 and goes up. So it was this one here. It was at negative 2, 8. We got to move it over 2 to 4. Multiply the negative 8 up to here, and then move it up 2, and there we go. And there is my new graph. That looks like that guy. So we can see that it's inverted, right? So we know that this has to invert it across the x. So everything that was here flips upside down. Everything that was here flips down there. And we can see that does happen. We can see it shifted over 2. So the center is shifted over 2. And it is moved up 2. So the center now, instead of being at 0, is moved up to 2. So everything is right. And we should be able to see that. All right, so I'll let you kind of try these on your own. What I want you to try to do is try to graph them without the table, because it's significantly faster to do it without any form of table manipulations. Just being able to see what does the standard function look like and then move around. So try that, the approach that I'm showing you. All right, so here, if you got this right, what we did, so let's look at this first red point. We know I'm shifting it over 3. So if I shift it over 3, we end up, so if I shift over 3, that point right there, and then reflect it over the negative, so it still stays there, but then move it down 4, we get to that point. This blue one here, same way, move it over 3, make it negative, and then move it 4 more down. We get to right there. This green one comes to right here, and our purple one that was right there comes over here. So that becomes our new graph. All right, so here we can go with number 11. Let's go ahead and describe all these. Well, I kind of just rewrote this a little bit just so you see it a little differently. So this negative 2 here would be a vertical stretch. So the negative would be a reflection, right? So this is going to be over the x-axis. So that's going to be some kind of reflection. The minus 3 down here at the end. So this minus 3 right there is going to just then move it down. So we know it's going to just go vertically down by 3. So that would be all our transformations that we have to be able to explain. And you should be able to do that on this one as well. So if I want to try to explain 13 and just be able to do all those things and be able to write the equation for that, well, I can say, well, my equation is based off my parent function, so it has to be some kind of cubic function here. We know, so I'm going to shift it downward by 1 unit. So if I shift downward by 1 unit, right now that would be x cubed, and then I'm subtracting 1. If I horizontally shrink by a factor of 5, well, what does that mean? Horizontally shrink by a factor of 5. So we still have our minus 1 over here at the end. Well, remember horizontal, anything horizontal is opposite. So anything horizontal is opposite. So I know that I have then, I'm going to put something here, and I got a cube there. And if I'm, so this would be multiplied by 5, and here's my x, that would be part of the x cubed. And horizontally shift left 4, so that means I'm going to be, this has to be plus 4, and a 5 multiplied out there, out front. And there is my, all my shifts. Okay? So that would be the equation, fx equals 5x plus 4 cubed minus 1, and that would give me an explanation for this. All right, so this one, if I have, let's just say I have this cube root, well, it doesn't really matter what this is. I can still apply the same transformations, right? So if it's going to reflect in the y-axis, I can say, well, that would have to be something inside here. Shrink vertically by a factor of 1/2, so I'm going to multiply this by 1/2, and then shift upward by 3/5. So that would be that, and that would be my function in my equation for number 4.